Here are the solutions to the geometry and statistics review. When a triangle GHI is reflected over the x-axis, what are the coordinates of the point that corresponds to G? So here is the pre-image of G. So the image of G would be the one that is reflected over this x-axis here. So here's the mirror that we're looking at. So as many spaces as there are above this mirror, we would need to go below to get to G prime. So 1, 2, 3, 4. So how did I know that G prime was 4 spaces away? Well, the 5 represents how many spaces across the x-axis, and 4 represents how many spaces on the y-axis. So I knew that G was 4 above, so G prime would have to be 4 below. So it's still 5 across, still 5 here, but now it goes down to -4. So the coordinates of G prime would be 5, -4. If point A, which is -3, -6, is translated 10 units left, so left and right means that it's happening to the x-axis, since the x-axis goes left and right. So that means that the x value is being decreased by 10. And 2 units down, well, 2 units down represents the y-axis, so I know that the y coordinate is being reduced by 2. So if it's going left, it's subtracting 10. If it was going right, it'd be adding 10. If it's going down, it's subtracting 2. If it was going up, it'd be adding 2. So what's the ordered pair of the image of point A? So A prime, I need to take my -3, which is my x value, and subtract 10 from it. And for my y number, I need to take -6, which is my y, and I need to subtract 2. So A prime is going to be -13, -8. Number 3. The two triangles below are similar. What scale factor can you use to find the length of the smaller triangle from the larger triangle? So in other words, the larger triangle is being reduced, and since it's being reduced, we know that K, which is the scale factor, has to be less than 1. So when in doubt, just pick 2 corresponding sides, like 90 and 72. If you did 90 over 72, both of those divide by 9, so that would give us 10 over 8. Both of those divide by 2, so that would give us 5 over 4. Or if you just used your calculator, that would be 1 1/4. So I would know that that's incorrect because I know that it has to be less than 1. So that's how we know to put the 72 over the 90 instead. And so when we reduce this, we end up with 4/5. So that's our scale factor because that is indeed less than 1. What is the measure of QRS? So where is QRS? Q'd R to S. So this is the angle here that I'm looking for. Explain your answer. Well, first step, we know SMAT 180. So we know that these 3 angles here have to add up to 180. So my first step is going to show and explain how to find this angle right here. So I'm going to take 85 plus 40, which is 125, and then I'm going to take 180 minus 125, and that's going to be the value of 55. So I know that this angle inside is 55. And then I also know wherever I have a straight line, they add up to 180. So my second reason is because of supplementary angles. So I'm going to take 180 minus 55, and that's going to give me 125. So this angle right here that I'm looking for is 125 degrees. I also could describe it and explain it that this angle is equal to the sum of those two, which is one of the rules that we talked about in class. All right, number 5 kind of looks confusing, but a right triangle has legs of length of 5 units and 11. Okay, so 5 and 11, and we know this is a right triangle, and so that's our side C. 4 of these triangles right here, 4 of these triangles can be arranged around a smaller square with sides equal to 11, 5. -5. Uses information to find the area of the larger square and the length C. Show your work on a separate paper. I'm just going to do it right here. So if I know this side C, which happens to be every side, then I'll be able to find the area of the square by just taking and squaring one of the sides. Or I could use the formula for a rectangle. Since all squares are actually rectangles, I could just find the value of C and then just take length times width. So no matter what, I need to find out what this number here is going to be. So a squared plus b squared equals c squared. So I'm going to just make this a and b. C is always the one that we know is across from the right angle. So I'm going to put 5 squared plus 11 squared equal to c squared. So 25 plus 121 equals c squared. They're on the same side, so I'm just going to add them together. And then to find out what c is, I'm going to take the square root of both sides. So c is equal to the square root of 146, which is an irrational number. So I'm going to just leave it like that for now. So I know that every side is the square root of 146. And again, I'm not putting that into my calculator because it's going to give me a decimal that never ends, never repeats. So I'm going to leave it just like that. So now what I have to do is take the square root of 146 times the square root of 146, which is just going to be 146. And so I now know the area of this square. Two angles are complementary. All right, so let's sketch it. Here's my complementary angles. Remember, it's always the right thing to do to complement somebody, so it's a right angle. One angle is 6 degrees less than twice the other. So 2x minus 6, because less than always reverses the way that it's written. What's the measure of each angle? Well, I have to remember that this missing angle is the x. So I'm going to add them all together. So 3x minus 6, put it equal to 90. Solve by adding 6 to both sides. So 3x equals 96, divide by 3, and x equals 32. So now that I know x is 32, now I can determine the measure of each angle. So x is 32 degrees, and then 2 times 32, minus 6, is going to be the measure of my other angle, which is 58. And they do add up to 90. So 58 and 32. Number 7, find the distance between the 2 points. So I'm just going to use the distance formula, which is on your formula sheet. So x2 minus x1 squared in parentheses, that makes a difference, plus y2 minus y1 in parentheses, so the quantity of, and then square it. So I'm just going to carefully, I'm going to put my x's first. So 3 minus a negative 2, and then use the parentheses, square it, and then 4 minus negative 3, close the parentheses, and square it. I'm just going to double check. So when I subtracted my x's, I went top minus the bottom one, and that's correct. So I have to do the same thing with my y's. Top minus the bottom one. I can do my change on those minus signs because they're inside the parentheses. Keep the parentheses because you never know when you're going to end up with a negative number in there. So it's just a good habit to keep them in the parentheses. So that's going to be 25 plus 49, which is the square root of 74. And when I put that into my calculator, I'm rounding it to 2 decimal places, which is going to be 8.60. So 8.60, because you can't really see it down there. All right, number 8, suppose a person starts at a flagpole. All right, let's draw our flagpole. And walks 200 yards due west. So west is going to be this way. That creates my right angle. And then 300 yards north. All right, so that's going to be 300 north. How far is the person from the flagpole? Okay, so here's another right angle. So I thought it was going to be this one, but it ends up being this right angle over here. So I'm actually looking for side C. So a squared plus b squared equals c squared is the Pythagorean theorem, and we use that anytime we're trying to find the missing side of a right triangle. So a and b, so 200 squared plus 300 squared is equal to the missing distance, c squared. So 4 with 4 zeros and a 9 with 4 zeros equals c squared. Add those together. So 13, 1, 2, 3, 4. So 130,000 equals c squared. But I don't really want to know c squared. I just want to know c. So I take the square root of both sides, and that gives me 361 yards. All right, number 9. So the following graph shows 10 points and 3 possible best fit lines. Which line, J, K, or L, seems to be the best fit line to the data? So here's my points. Those are important. So those lines, if we imagine them as a school of fish, are swimming in this direction. So K is our line of best fit. Number 10, Maddie did an experiment with 10 points. All plants were 4 centimeters tall at the start. She put 2 plants in sunlight for 1, 2, 3, 4, and 5 hours per week. Then she measured and plotted the heights of each plant. So looks like plant 1 was 6 and 7. Oh, looks like her different plants. Okay. If I see, never mind. Let's backtrack. So that isn't plant 1, that's the hours of sunlight per day. Then she measured and plotted the height of each plant. An appropriate line of best fit is drawn. Okay, so if the plant had 1 hour of sunlight, then it was, one plant was 6 inches, one plant was 7 inches. If it had 2 hours of sunlight, one plant grew 7 inches, one grew 8, and so forth. So the line of best fit is shown. Identify the slope of the line and explain the effect in hours of sunlight on the height of the plant. So basically I'm just explaining what the slope would mean, and identify the initial value and then interpret its meaning. So let's do slope first. So I might be able to get away with doing rise over run, so let's check that first. If not, I'll have to use the formula, but I might get lucky and be able to just calculate it by counting. So we are counting, every line is 1. 1, 2, 3, 4, 5, 6. Even though they numbered them, every other line, they're still counting by ones because of the lines in between those numbers. And they're also counting by ones here. So these look like 2 perfect points, so let's use those. It goes up 2, so it rises 2, and then it runs 1. So our slope is 2. So what does that mean? So we always describe it using our y-axis first. So that's going to be centimeters per hours of sunlight. So as a sentence then, if I were to describe that, I could say that each plant grew 2 centimeters for every 1 hour of sunlight. All right, and now let's find the initial value. The initial value we already know is right here. The initial value was, the initial value is 4, which is the height of each plant at the start. And we could even elaborate more. We could even say of the experiment, and we could go into more details if we needed to. Number 11, what is the slant height of the square pyramid? So this is the slant height right here, okay? So that is our slant height. So this, if you don't recognize it, is actually going to be a right triangle. So let's just kind of take it out of that pyramid so it's easier to see. So we're trying to find this side here, which is my slant, and it's also going to be side C because it's across from the right angle. And this length right here is only 4, not 8. 8 goes all the way across. So a squared plus b squared equals c squared. So 10 squared plus 4 squared equals c squared. So 100 plus 16 equals c squared. So 116 is c squared. And take the square root of both sides. We're rounding it to the hundredths place, which would be 10.77 centimeters. A cone has a circular base with a diameter of 8 and a height of 12. If the volume of the cone is n pi cubic centimeters, what is the value of n? Let's draw our cone. And it has a height of 12 and it has a diameter of 8. So the volume we know is n pi right here. So what is the value of n? So it's going to be a work backwards problem. So the formula for the volume of a cone is 1/3 times pi times r squared times h, which is the height. I know that the volume is n pi because it tells me so right here. I'm going to keep the 1/3. I'm going to keep the pi since they kept the pi. And then I'm going to change my radius to 4 and square it, and the height is 12. So I'm going to try to clean this mess up a little bit. So I am going to just grab my calculator and I'm going to kind of do all of this multiplying. So I'm taking 1/3 times 16 actually, because 4 squared is 16, times 12. And that's going to give me a 64 with a pi symbol after it. So when I multiply those three numbers, I end up with 64 pi. Well, if I divide both sides by pi, the pi's are going to disappear. So n is equal to 64, which is what they were asking me in the first place. Number 13, which of the following is the equation of the estimated line of best fit? So here's my points, here's my line of best fit. Well, that's kind of hard to determine. So let's just look at our choices here. So we want these all in y equals mx plus b form, which means those need to be reversed. So let's just rewrite that as y equals 19x plus 0.75. And let's rewrite this one as 0.75x plus 19. That one I don't need to rewrite. Although I can eliminate that right off the bat because it's a vertical line. So I know the answer isn't going to be C. Because if it only has an x, it's a vertical line, and that is not a vertical line. Vertical lines look like that. So I know it's not that one either. So then y equals negative 0.75x plus 19. So what I did is just reversed all of these because usually we always write it with our x term first. So the initial value, let's see, do any of those help us eliminate any more of our choices? Well, that number there looks pretty close to being 19, so not 0.75, so I know it's not going to be A. So my choices are either B or D. So they both have an initial value of 19. So I can actually rule out letter D also. I can rule this one out because it has a negative slope. And this line has a positive slope. Remember, if it's going in this direction, it's positive. So there's my answer, letter B. Okay, so 50 students answered 2 questions about whether or not they like 2 vegetables, peas and carrots. The results are shown below. Calculate the relative frequency as a simplified fraction of students who like peas, given they didn't like carrots. So let's finish the table. 31 plus 6, 37. 4 plus 9, 13. 31 plus 4, 35. 6 plus 9, 15. 37 plus 13 is 50, which it's supposed to be, so that's good. And 35 plus 15 is 50 also. Calculate the relative frequency as a fraction, simplified, of students who like peas, so they like peas, given that they didn't like carrots. So that means that they liked peas, didn't like carrots. And then this key word here, given, tells us that our denominator has to be the total of the students, excuse me, the total of the students that didn't like carrots because of the word given that they didn't like carrots. So that means the total of students that didn't like carrots. So let's now look at our table. Peas and didn't like carrots. So likes peas, did not like carrots is a 4. And the total of students that didn't like carrots. So let's find the words don't like carrots. Here it is. So do not like carrots. So I have to look over to get my total, which is 13, and that is already reduced.